Okay, so this is chapter 5. So chapter 5 is about sequence. So what is sequence? Sequence is some numbers that are put together like here it's the 1, 7, 4, or 5. Those are sequence, right? Just some numbers, a list of numbers. So we have many those sequence. So here we just focus on some typical sequence. So simplest sequence is arithmetic sequence. Just like this, 1, 2, 3, 4, 5, or 5, 7, 9, those sequence. Those are arithmetic sequence. So we can see that from those two examples, we can say what is its characteristics. So we find that for those sequence, like this start from 1, then increase by 1, increase by 1, increase by 1. So this one increase by 2, by 2, by 2, right? Or so we can say the neighborhood, the difference neighborhood, the difference between the neighborhood is a constant. So this actual definition for arithmetic sequence. So what is arithmetic sequence? So we say if the last one minus the previous one, the difference is d, is a constant, then this sequence n is arithmetic sequence, and this d we call it the common difference. Okay, so for a arithmetic sequence, we say like so an minus 1 is d. So in general, so we say like here n here this its neighborhood their difference d. There's d, then there's another d. So in general, an minus am equal n minus md. So typically, so an minus, so we say an minus a1 equal n minus 1d, right? Or an equal a1 plus n minus 1d. Okay. So for those arithmetic sequence, we want to find summation of those sequence or sum of those arithmetic sequence. For example, we want to find this 1 plus 2 plus 3 plus 99 plus 100. So for this one, we can, if we added one by one, this will take too much time. So here we can find like this like 1 plus 100 101, and 2 plus 99 is 101. So we just put like we put the two numbers like 1 and 100 together, 299 together, just like that. 100, right? 299 and 398, right? So go down, and 50. I think it's 51, right? So we just put the number like says 50 pair. Okay. So 1 plus 100 is 101. So we have, so this sum is 101, 101, 101. We have 50 of 101, right? Okay, so in general, so we can also so we can give the formula. We say this equals this plus this, a1 plus an divided by 2. So each one is just divided by 2. Then multiply A1 plus A2. Just divided by A1, so we have this formula. So we don't need to remember this formula, but we should remember this idea. Okay, we just check this one or first one, put the first one and the last one like this way to find the summation of arithmetic sequence. Okay. So for this problem, let's say, so we say the 3, so this is equal to 3 plus 203, right? Okay, so we just said, okay, that's one term and then just this plus this. So we just want to find how many terms, so we have this formula, right? This plus this multiply how many terms divided by 2. Or we can say like how we can say like this plus this plus this, so we have n over 2 terms, right? Equal 206 multiply how many? So 206, we have n over 2 terms. So what is n? So here n. So how can you find n? So we just check. Okay, so this 206. This one equal, so minus first one is equal n minus 1 times d. Okay, so last one, first one, so suppose this is first one, this is n, so n minus a1 equal n minus 1d. So here, what is d? D equal 1, right? So d equal 1. So we can easily find a. Okay. Now for this one, so I did this plus this. I just said 3 plus 203. So then, how many terms? N over 2 terms, right? So what is n? N we need to find this way. So we say 203 minus 3 equal n minus 1 d. So what is the d here? D is 2, right? So from here we can find n. So let's say that here is 2. Yeah, we can easily find n. 200 equal n minus 1 times 2. Okay, so this n minus 1 is 100, n equal 101. Okay. Okay, yeah. So for this one, same way. Okay, so it's equal 5 plus 145. Okay, multiply. So multiply how many? N over 2, right? So what is n? So here we want to find n. How can find it as n? So we say like, oh, this one, last one. We regard this is first one, this is n. So minus 5 equal n minus 1 multiply d. So what is d here? D equal 4, right? So d equal 4. So from here we can find this n, right? So 140 equal n minus 1 times 4. So we can find n, yeah. So we can plug in. Okay, so for this problem, we just use the formula. Let's say this is equal. So we say this equal 2 plus 34. So n over 2. So we have n1 over 2. So we need to find how many n. Yeah. And this one, so 3 plus 51. So n over 2. But we have n2 over 2, right? So here we just need to find what is n1, what is n2. Okay, so n1 equal what? n2 equal what? So we just need to find this. So how can we find n1? So we say 34 minus 2 equal n minus 1 multiplied d. So here d is 2. So from here we can find n1. And for n2, we say 51 minus 3 equal n2 minus 1 multiplied d. So here d is 3. So we can find n1, n2. Then we can find this number. So here just a little bit calculation, right? So let's say for this one we can say or divide. So n1 over 2, n2 we can cancel the 2. So this is equal like 36 n1 over 54 n2, like this, right? So what is n1? n1, let's say, so n1 minus 1 equal, multiply 2 equals 32, so equals 16. So this equal 17, right? And 50, let's say, so what is n2? So n2 we just divide by 3. So divide by 3, so this equals 17 minus 1 equal, divide by 17 minus 1. Oh, same 17. So cancel. Then also can simplify, right? We can get we can get the answer easily. So for this problem, it says this apple ate 100 delicious yellow bananas from May 5 to May 1st and May 5. So first day, May 1, May 2, May 3, May 4, May 5. Okay. Each day he ate 6 more bananas than on the previous day. So first day we don't know. Suppose first day ate A1. Then here is A1 plus 6. So A1 plus the plus 6 become A1 plus 12. So A1 plus 18. Then A1 plus 24, right? So totally is 100. So we need to find A1. We need to find, yeah. So what is the question? How many banana did A1 eat on May 5? So we want to find this number. Okay. So find A1. So we just say add them up. We have 5A1 plus, let's say 6. Let's say, so here's 6. So 1 plus 2 plus 3 plus 4 equal 100. Okay, so we divide by 5. So A1 plus, so this is 10. So divided by 5, so it's 12. 520. Okay? Divided by 5. Yeah. So A1 equal 8. Okay. So this number is 24 plus 8, 36. No, 24 plus 8, oh, 32, yeah. Okay. So we have a stair step. A stair step figure is made. So just like that. The first one black, white, then white, black, white, just like that. Okay. Okay. So the question is, in the 37th row, how many black squares? So here we just try to find a relationship. Like suppose there's a first, let's say first one, there's a second one, there's 30 row, fourth row, okay, and the fifth row. So here is we just check a relationship with row and the number of black. So number of black is 0, here's 1, here's 2, here's 3, right? Okay, so the question, if this is 37, so this is very easy, you can find, right? For you can find it 36, right? There's a problem. Which of the following sets of whole numbers has largest average? Largest average. So let's check. Let's say A is multiple of 2 between 1 and 101. So A is just 2, then 4, 6, then 100, right? So we say this is for A. Then for B is multiple of 3. So could be 3, 6, and 99, right? Multiple of 3, multiple of 4. So this is 4A, then here 96, yeah. So multiply D, so multiply 5, so 5, 10, 100, and E multiply 6, so 6, 12, like that, and let's say, and here 12. So let's say 6 multiply 6 multiply 13. Oh no, 14. 14. 15, 19. Oh, how about 16? Oh, okay, 16, right? 96. Yeah, 96. Okay. So we want to find their average. Okay. So their average. So we say those number. So the average. We can use this. So here maybe we need to do some calculation, find the average. Okay, so let's say we just check how many terms. So for A, we can take 2 outside. So 1, 2, then 50. Like we have 50 of them. So for those 50 numbers, the average is middle one. So 50. So we have 50 so here 25, 26 middle 25, 26. So that's equal to 25, 26 over 2. So this is just 101. Or we also can say like how can find the average? Average is like added up divided by n. So let's say here maybe you can use this formula: a1 plus a2 an divided by n over 2. So this is a sum of them. So average divided by n. So we can say average actually average. Here we have a formula for average for an arithmetic sequence is just the first number, just equal first number plus last number divided by 2. So we don't care what is the n. Okay, then this, so we make the problem easy. So first one is just this times this divided by 2, so 101. So this average, this plus this divided by 2. So this is 1. Oh, no. I'm sorry. 102 divided by 2. Yes, this is plus this divided by 2. 102 divided by 2 is 51. And then this, so this equals 3 plus 99 over 2. Yeah. So this is 4 plus 96 over 2. And 5 plus 100 over 2. Then maybe we have forget over 2. So this is last one is 6 plus 96. So this is 102. And this is 105. Yeah. Okay, so we can find this D is largest than 105, right? Okay. So this problem is a typical problem. Like we know A4, A10, we want to find A100. So we can use this. We say A100. We can equal, so equal A10 plus 90D, right? So what is D? So 18 is equal to 25. So what is D? So D, you say 18 minus A4 equals 60. So this equal 25 minus 7 equals 60. So what is D? D is just equal this divided by 6, right? 25 minus 7. 25 minus 7, 18. Yeah, or 18 over 6. So that's equal 3, right? So this is just equal 25 plus 90 multiply 3. D equals 3. Okay. Okay. So we have some example, some problems. We just need to find the addition of a arithmetic sequence, like for this problem. So maybe we can do this way. Oh, add this up, then add this up. But here we have a quick way. We find like 1 plus 9 is 10. 11, so here 30. So this is just 10 plus 30 plus this 50 and 70, and 90. Right? We can show easy way. Then put this 100, 100, so there's 250. Right? So this we have a quick way or easy way to find the addition. So for this problem, same way. Okay, so we can check this first. This thing, this another thing. Okay, then another thing. So here we need to check like okay. So this minus this first one, this is 30, this 10. So 10 plus 10 plus 10 plus 10. So how many those? Okay, so we just check like okay, from 99 minus 98, saying so we just check it. Let's say goes down to 30 minus 20. So how many terms? Just like find n equal what? Okay, so we just check like what's the next one? So next one, 1970 minus 1960. Okay, so from here to here, that goes down 20, 20, 20, 20. So we can check this. So we can sequence like 20 of, let's say, saying maybe 40, yeah, saying to 1980. So we need to find how many those terms. So we can say how many, we need to find a, so this equal this minus this equal, so n minus 1 times d, so d is 20. Okay, so we can cancel 20. So let's say a0 divided by 20 divided by 2, 99, right? So this divided by 20, so this become 99 minus 1 equal n minus 1. So n equal 99. Okay, so we have a 99 for this term. So this equal 99 multiplied 10 plus one more 10. So this equal 99 plus 1, 100 times 10, 1000. So for this problem, so let's say, yes, same idea. We just put this as 1, this is 1, then this is 1, this is 1. Okay, so then, so we find, okay, so this plus this minus this plus, okay, so this previous one should be like minus 99, right? Then plus 1000. Okay, should be like that, right? Okay, so we say like here 1, 1. So we just check how many ones. Okay, so how many ones? So we just check this number from 2, 4, 6 to 1000. How many times? N equal what? I think it's 500, right? So we have 501. So multiply 4. So we say we have 2000, right? Let's say so for this one, we just check 1 minus 2 minus 3 plus 4 plus 5 minus 6. No, oh, what's the rule for this source sense? 1 minus 2 minus okay, let's see. Let's say maybe the check it 2 by 2. Negative 1, positive 1, negative 1, positive 1. Oh, so negative 1, positive 1. Oh, so we say negative 1, positive 1, negative 1, positive 1. Just try to cancel them. So negative 1, positive 1. So here we need to find, let's say, this is negative 1. This is positive 1. Negative 1, positive 1. Okay. So we just check this number. Okay. 2, 4, 6, 8. So here's a negative 1. This is positive 1. Negative 1. Positive 1. Positive 1. So we just try to find. So let's say. So this number is 1998, 1996. So this one, positive 1. Okay. So we just find what this number. So this number is positive 1. So add them up, cancel, cancel, cancel. So this becomes 0 or 1. Okay, so we just find it. Okay, so this is 0, this another 0. So we need to find so. So what is the relationship? So if not, this last number is a multiple of 4, then let's see. So here 0, here 0. Okay, let's 10 and 12 is another. So we just need to find this number 96 is 4. Okay, so if this is the multiple of 4, then we find this is becomes add them up, it becomes 0. So we say this is actually is multiple of 4, right? Let's say okay, so we say this is multiple of 4. So addition is 0. So we just check if let's say 1 this is if the last one is 2, this is negative 1. Then positive 1. So if this negative 1. So if we at end with here, the answer is negative 1, right? If answer is here, then 0. Okay. Okay, so for this problem, also, this is easy. We just check it. Okay, so here 1, 1. Oh, this is easy. Yeah, 1, 1, 1. Oh, this is just 5. Yeah. Okay, then negative 1, negative 1, negative 1, negative 1. So negative 1 or negative 4 plus 9. Okay, this equal 1. Okay, so we also can do this way, right? Okay, let's say we can combine of, we just put this as 1, right? So 1, this another 1, right? And this is 1, and this is also 1, right? So 1, 1, 1, also 5. Okay, so we can stop here.